All right, so I hope you're ready for another loop challenge here. And in this one here, we need to calculate the sum of the odd numbers that are greater than 10 and less than or equal to 30. All right. Now we want to do this with a for loop and utilize an if statement. We put a bonus in here so that way we can do this without an if statement. If you watched the previous video, you might know how to kind of approach this, at least the looping part, right? Because we're doing a little bit different things in this one because instead of just printing them all out, we want to add them up. And so one that we're going to do first here is with the if statement. Now, whenever we create an accumulator, right, we need to create a variable that is outside of the loop so that way we can print the final total. We don't want to continually print it out all the time, but we want a place to store that value. So what I'm going to do here is I'm going to create a variable here called sum1, not like somebody, but just sum1, and we're going to set that equal to 0. Now the next thing that we need to do is we need to create a for loop. All right, so I'm just going to use that keyword for, and I'm going to put inside here the variable. I'm going to create that let I equal 11. Notice that way I didn't put 10 in here, right? And that's because I know I'm smart here. I don't need to put 10 in there because it's not going to be needed. Now I technically could change this to 29 because I know that 30 isn't an odd number, but we'll make this the conditional here. We want to stay inside this loop as long as I, which is the iterator, as long as it's less than or equal to 30. And then over here on the far right, we're just going to increase it by 1 each time to kind of go through the loop. Okay. So the idea behind this is inside here, we need a conditional. We need an if statement saying, if this thing is odd, then let's go ahead and add up whatever number we're on to the sum. Okay, so let's go ahead and do that. We're going to say if I modulus 2 doesn't equal 0. Okay, now I want you to recall what the modulus does here. It's taking the remainder. Okay, and let's use a real number on here. Let's use 8, for example. 8 divided by 2. What is the remainder? Well, the remainder is 0. Well, that's even. 8 is even. Well, what if we use 9? 9 divided by 2. What is the remainder? Well, it's half of it, right? It's 1. And so it doesn't equal 0. That's the key part here. If we put 9 in here, divide by 2, the remainder is not 0, which means that we fall down here into this use case. So again, we're going to do sum, and then we do the plus equals. Again, that's the same thing as sum1 equals, and then whatever sum1 was before, and then added an I to it. So this is just a real shorthand way of doing that. And then the last part here is we need to match up these colored brackets here because we are done. And then we can come over here and we can just do a console log of sum1. Okay, so let's go ahead and save that and run it. And then we get 200, as you can see up here. Okay, so that's one way of going about this. Let's go ahead and refactor this. Feel free to pause the video, see if you can refactor it based off of the previous video that you've seen about loops from us, and see if you're able to solve it. So go ahead and create a brand new variable here. We're going to call this let sum2 equals 0. Again, we still need that accumulator bucket variable outside of the loop, and this is what we need. Okay, we need our normal for loop. Okay, everything's looking the same so far, right? If we look at this, we have 11. We have our same conditional here. Now the only change is that we are adding 2 to each time we loop through it instead of adding 1. And then the last thing that we need to do here is we're just going to console log the sum2. And again, if I save this and then I highlight just this and I run it. Let's go ahead and hit the play button. I still get 200. All right. So again, that's another way to do it. We have accomplished both tasks. This one down here would probably be the preferred way of going about it because we're staying in the loop a little bit less. Are we really going to notice a difference with it? Something this small? Probably not. Okay. But we can kind of even take a look here, 0.052. Let's go ahead and run this one, 0.072. So just a little bit of difference, and that's just because we are adding an extra time every time we're going through that, right? All right. So hopefully you ended up getting that. Hopefully this made sense, and we'll see you in the next video.